Welcome to the session. Greeting of the day. In the previous classes, we have talked about the various welding, weld joints and welding classifications we have did. In continuous with that, in this study, you will see about the zones in the welding processes. Here, we can able to see the welding has been completed with respect to specimen 1 and specimen 2. After welding, how it looks like this. I have given the various names to this terminologies of various zones. So I am giving, we know this green zone, which is where the filler metal has been consumed, melted and deposited inside. We have studied the various regions of root gap, root face, right? Those things it will fill completely. With respect to heat formation, it melted and deposited and filled. Here it is filled likewise. Right? Here it is filled. Right, okay. So those region I am calling it as a weld metal. So this only the green zone I am calling as a weld zone configurations. Right? So now, even though the melted heat falls in the weld metal, the heat distribution occurs through to the material. It is melted, deposited, that we know. But you see, the distribution of heat, not only it is here, it absorbed by each point of the base material. Therefore, the zones where I am calling for a small zone where the heat is distributed up to this zone, at the both sides it will distribute, not only the one piece, because two are we are welding. So two sides are there. I am calling the zones as a heat affected zone. Heat is only affected, not melted. Here at the faying surfaces, the surface which is in contact with the mortar material and it is melted and the welding has been done. But the nearby area, nearby zone of the workpiece, it's not melted. The heat is distributed, heat is absorbed by heat less than the melting point of the workpiece. Therefore, the zones are called as heat affected zone. But there is a metallurgical changes due to heat. After the temperature increasing the stainless steel above 723 degrees centigrade, the phase changes occurs. Those things will happen. Those phase changes will change the mechanical properties of the material. Therefore, this heat affected zone is very important to maintain very minimum heat zones and very minimum heat distributions also. If it is a large heat affected zone, heat is affected, then probably the mechanical properties are also affected. So that is a very important point where we have to take care. Before, this boundary is there, see, this is the weld zone and here there is a boundary. This boundary zones, I call it as a weld zone. So I am calling this as a weld zone. So weld junctions are not weld zone, weld junction. I am calling this as a weld junction. Weld metal, after junction, weld zone comes. So we have seen these three. When is a weld zone? You see, the combination of weld metal and the combination of heat affected zone is called as a weld zone. Right? This is weld metal and then the heat affected zone. All together I am drawing a line here. So up to this point. So here, this is interconnected up to this and interconnected here. So this zone we call it as a weld zone. Weld metal, heat affected, weld zone, weld junction. These terminologies we should know before going for the fundamentals of welding processes. Simply going for welding process, taking submerged welding, taking manual metal welding, that is not the process understanding. We should know first these things. Then we go ahead. Right, now, see, I am telling, we have prepared two pieces. We have prepared the two pieces like this, and we have started to weld in this zone. At this point is there, you see, I am drawing here. This point. So this point is called as weld toe. This point is called as weld toe. This point, see, both are same, weld toe, and here also I have drawn the about weld toe. This point, this corner point of the piece 1. Similarly, that side also weld toe is there. Okay, so weld toe they are calling. And then the fusion zone, maybe the weld metal, this is total weld metal, I am calling as a fusion zone. Here the fusion occurs. You understand the word, the word says everything for us. The fusion between the base material and the filler material, we can write here. Fusion of filler plus base. Okay, base surface. So this we call it as a fusion zone. Okay, now we got the point where we are going. And then we know this root. We know this, usually this root we know. You see, the root gap. In the previous we have studied about this point as a root gap, the 1 mm or 2 mm, and this point we have said is a root face. So that is what they have given by identifying as a red point. They have given as a root gap. You can write gap. Root gap, how much? This point is root gap. This point is a root gap. You see? So earlier we have seen about the various zones. Now we have to see about the weld features. The same. Again, the root bead width. So here the root gap is there. Root face, root gap. In the root gap, that is before welding we have seen. After welding, it is penetrated to the 0th mm. Here the 0th mm is there. Here the 0th mm. Maybe here the maybe 16 mm. We can keep 16 mm pieces. Okay, 16 and 0th mm. So full penetration, how we can call? If it is welded up to this location, defect is there. Where is the defect then? Here you see, defect occurs there. It is not filled zone. It is not filled zone. It is not filled zone. Okay, so we should fill. How we can fill them? So when it is filled completely after 0th mm, I am calling this as a full penetration zone. So now here, this is full penetration. After this zone is called as a full penetration. We should come down little. For that we should not come down up to this much. That also defect. Okay, that is also the defect. So this gap, root bead width. This gap we call it as a root bead with how much the width occurs. If it is welded and solidified like this, it should not go. Okay, we should keep remember. And then I am telling about the weld cap width. Similarly, this is we talked about the penetration, root bead width. Similarly, I am talking about the top one. So welding the specimen 16 mm is up to here. Up to here. So what is this one? This is a height. See, up to here we have welded. So that I am calling as a excess cap height. So this is like a cap. So up to this is 16 mm thickness of the plate is there. And we have welded extra. Not extra, the sufficient we have done. The cap height. It should not be extra. It should not be extra, but cap height is required for the complete filling of the 16 mm. If it is 16 mm, we should go for 16.5 mm welding. It means the weld to be 2 to 3 mm higher, 2 mm higher, 1.5 mm higher, but not 6 mm higher, 7 mm higher. That is wrong. Okay. Therefore, this height is called as a cap height. If it is more, we call it as a excess cap height. That should not be done. So we are talking about height. We should talk about the width also. So I am talking here from here to here. This length. So this length I am talking. Okay, welding cap width. How much it will be? We have taken edge preparation this zone, and we have taken the edge preparation this zone, and also we have given the root gap of this zone. This all together forms this weld cap width. If you are not giving the weld cap with this one, weld cap will be this one, then electrode will not go down inside to the 0th point. To the 0th point it will not go. Therefore, this bevel, this V, and then the cap will form, but it should be in limit, not in the excess. Okay, so these things we should name. So here see, excess penetration. That is what I told you. It should be like this only, little bit, not the excess. Excess is not good. This excess point is not good. It should not go like this. I should not weld. So excess is not good. Excess penetration is not good. Excess cap is not good. But full penetration is needed. Okay, so that is so far about the butt configuration. This is about the butt configurations. Now we want to see about the fillet configurations. So I have taken a corner joint and I have done a fillet welding. This zone when we are welding is called as fillet. There is no edge preparation is done here. There is no edge preparation is done. We have kept as it is 2 points and we have done the welding, which is called as a corner joint. We call it as a fillet weld. So here I want to talk about this terms. This is the height. We call it as a vertical leg height. This is called as vertical leg height on the fillet weld. Similarly, this is called as a horizontal leg length. Horizontal leg length. Where is the weld zone? Where there we have talked about weld zone. Here we have this starting of the green first point here to here. This we call it as a weld zone. How much depth I can able to do like this. I can able to do like this. I can able to do like this. I can able to stop. So nominal design throat thickness is there. Up to that we have to do. That is the design process. Okay. So this is about the terminologies in the fillet weld. Butt weld, fillet weld. So similarly, there are possibilities of there. What are the possibilities? I am telling. Fillet weld can be the meter fillet. It means the flat. So here you see in this diagram, it is simple flat is there. A simple flat. Okay. There is no curvatures are there. It may be concave. It may be convex. So it all increases the stress points and the comfortable withstanding strength points. Okay, therefore, it is not to be a convex, right? It can be a flat. Okay, so this is gives, you see, fillet has been done flat. But here, the same fillet has been started in the T joint, in the T joint, in the T joint. But the fillet has been made as concave. But what I have done there, here the fillet has been started, but the fillet has been made convex. So this is not good. The concave profile is preferred. See, concave profile is preferred over the all ever others. For joints subjected to the heavy fatigue loading, here due to convex there is a stress point there. The stress point will be there. So that creates the crack initiating point. Therefore, we prefer this concave fillet welds. So this is about the 3 meter, concave, convex. Concave is preferred. Now we come to the welding positions. Very, very important. But with respect to these things, we qualify the welder. Whether he is qualifying in the 1G position, whether in the 3G position or the 6G positions, how the skill of the labor, which we are qualifying the skill of the labor, accordingly we will employ them to those corresponding locations. For example, I want to weld a plate in this such a way, say simply I can able to do here, the welding. This is called as 1G position. In case a complexity, overhead positions to be welded, the welder having the skill for welding in going position cannot be welded in this location because the motor metal will fall down. In such cases, welder have to be trained well, and then those trained welders to be employed for the welding in the overhead positions. Right? Such a qualification method is there with respect to various positions that I am telling. Okay, see? First one, the name given by USA standards, what they are telling, this as 1G position. What is 1G position? Just like that, a flat position. Just like that, I am keeping the electrode in such a way here. Okay, this pipe will rotate. This pipe will rotate, and simply here when your pipe is rotated, the electrode will consume and will be deposited. Okay, pipe rotating in a flat position. Similarly, in case I have a plate instead of pipe and plate, there are two combinations are there. Maybe a pipe, maybe a plate. We are manufacturing during the casting process. The plates are done, the bars are done. Those all comes under the plate. If not the plate, it can be a pipe. We are bending and making this a pipe for boiler plants. So such cases, maybe a pipe or the plate can be there. So we are qualifying the welder with respect to these categories. So here also 1G. Where he will weld now? Now he will keep weld the electrode in this way and goes in this path. So he will weld here. He will weld here. Okay, like this he will move. So this is 1G position, a simple flat position. Like this he will do. So for pipe, 2G fixed horizontal. So from the flat position I am coming to the horizontal position now. So I am keeping the welded position like this and I am welding in such a way. So pipe is fixed. I want to move from here to here. Okay, 2G, pipe fixed, 2G, pipe fixed. So you see, the next one, I am going, in case, the same, I am keeping the plate. So pipe horizontal 2G. Plate horizontal, what it is then? It is also 2G here. It is also 2G. I want to weld in this location here. I am keeping the hand horizontal and I am welding in this format. Two plates are there. Edge preparation single V has been taken, right? And the root face of the gap is given, and in the gap I am welding. So I am welding. I can weld horizontal. Okay. 1G pipe, 1G fixed and 2G pipe horizontal, 2G plate horizontal. Okay. Now we are talking about the flat and the horizontal. It means 1G position and 2G positions we have discussed. 1G positions, 2G positions we have discussed. Now we have to go for 3G positions. Here, the vertical positions are named as 3G. 3G positions. So see, the 3G plate has kept vertical, but I can able to do welding maybe from here to here. Welding can be done here like this. I can able to increase. I am moving the hand upward, vertical upward I am doing. Vertical upward I am doing. Otherwise, 3G, vertical downwards. I want to weld from here to here. No. So I can able to weld. So likewise, vertical downward or vertical upward, both belongs to 3G upward, 3G downward. Okay, now the complexity increasing keep on. This is easy, horizontal 1G, and this is little bit tougher as like our handwriting. Okay, it is 2G. And now instead of horizontal I am doing vertical up, vertical down. So that is called as 3G. Now we are coming back again. Some other difficulties. 4G we are coming. See the 4G categories. 4G. What I am doing here, I want to do overhead position here. So I am doing welding in this locations. I am doing welding this locations. Here I want to do 4G positions, overhead 4G. Now again the complexity increasing. It is a 5G. See the 5G position. This pipe is fixed. This is written here. The pipe is fixed there. In the vertical portions, already the flat portions we are kept like this. The pipe is rotated. The pipe is rotated. Okay, but here we have to move. I want to weld here in this location. I want to do weld here in this location. I want to do weld here in this location. When I am doing welding in this location, it is 3G vertical. When I am doing the same in the upward direction, it is flat 1G. 1G portion flat, keeping as it is. And when I am doing the welding in the bottom, it is nothing but a 4G, this location. So when I am doing for 5G welding, the welder is able to weld for 1G, 3G, and also the 4G portions. He is qualifying. If this weld is good, this all will be good. We understand like that. So the 5G portions qualifies the welders. Below this, 5G, if the welder is welded, he will do weld good in 4G, he will do weld good in 3G, he will do weld in the 2G and 1G also. So likewise. So next one, complexity further I am increasing. I am keeping the pipe as an inclined way. You see, it is very much more difficult than other things. What I am doing, I have kept the pipe rotating part in the angle of 45 degrees. Usually in the 5G, just now we have seen, we have kept in the flat way. And we have welded here, and we have welded at this point, and we have welded at this down point. 1G, 3G, and 4G, we combination called as 5G portions. But here, this is not like this. It is somehow inclined. So complexity much more changes. How he been? I can't able to weld in this 1G portion because it is inclined a little bit. The molten metal will fall here. So we should be skilled labors required here. Therefore, this inclined position, but it is fixed. Inclined position, but it is fixed. Pipe is fixed. We should incline the weld here and weld here. These locations we have to weld. And also here overhead portions we have to weld. Again that side. So 1G, 3G, 4G, inclined is coming. So this is called as a 6G position, very important one. If the welder is qualified in this 6G position, he can able to weld 5G, he can able to weld 4G, 3G and 1G. Everything is possible there. So most of the welders qualifying for this final portion of 6G. Now little bit, again I am making much more complexity, such inclined portions, pipe rotated. So I am calling this as a 1FR. So the pipe is rotating and we have to weld inclined here, inclined here, inclined here. So same 45 degrees maintained here also. Such categories are available in the positions of welding. Welding positions, as of now we have talked about the 1G, 2G, 3G, 4G and 5G and 6G positions. So see, this 1G is a flat, 2G is horizontal, right? 3G is vertical, and 4G is overhead, and 5G is pipe fixed. Here pipe rotating. Okay, and finally 6G, pipe inclined. Right? So this is how we have seen this various positions, very important for the qualifying of the welder. Now we come up the next step. Now we come up with the power sources. How we are going to weld? We know the specimen is ready. The specimen is ready now. We have taken this. Its preparation we know, positions we know, butt we know, flat we know, fillet we know, all. Now the specimen is ready. we have to weld. Electrode is ready. But how the heat is generated? Heat makes melting and dropping and filling. But how the heat is generated here? We need a power source to create the heating. So power source are apparatus that are used to supply a current and voltage that are suitable to particular welding processes. We know what is voltage and current, we should know. Voltage is nothing but a pushing of electrons. We have studied the energy band gap. Likewise, we have studied the energy band gap, the conduction band, valence band. Valence band, conduction band. Okay, this is energy and valence we know. Here, from the valence band, the electron should jump to the conduction band. From here, it should jump. And then conduction occurs. Due to conductivity, the heat occurs. Those heat, we are making the flow of electron we should do. How the flow of electrons will make? Here, from here, we should push the electron to go to the conduction band. So thus conduction is, voltage is nothing but a pushing of electron. But current is nothing but a flow of electrons. So this simple terminology you should know. Voltage is pushing of electrons and current is the flow of electrons. So such things are made by this power sources that we should see. See, the arc voltage power sources, the arc voltage requires that an electric arc be established between the electrode and the workpiece. That is what I told you. Here the workpiece is there, here the workpiece is there, and electrode is there. There should be arc to melt and drop down. So the electric arc to be established between the electrode and the workpiece to produce the heat, needed for melting of the base material. Okay, now we came. Because the utility energy is not delivered at a proper voltage and current, it must be converted to the required level of welding. The home applications comes under 240 volt, 480 volt, that this terminology we have seen. But the machineries, the welding setup machines works in 20 to 80 volt. So we should convert from AC to DC conversions. Those things we have to do. Therefore I have a setup of machines such as welding transformers, which supplies the AC, welding rectifiers, which supplies the DC, which is in the required formats, and welding generators, which can be utilized AC or DC by switchings, by inverter type, which gives the DC. Mostly we use those DC supplies for our welding process because the direct needed. There is no alternating of breakage is not required. Flow to be continuous, therefore heat continuous, therefore the heat deposited by melting of the molten metal, and therefore the melted molten metal drops into the workpieces and it is welding occurs. So the power source are utilized, we know positions, everything. Now we go ahead. Now we have to go to the how this heat generation occurs from the power source to the arc initiation technique. Fundamentals of arc initiation technique you should see. Arc initiation next. The welding arc is an electric discharge due to the flow of current. The word, see, flow of current from the cathode to the anode. Okay? The welding arc is an electric discharge due to the flow of current from the cathode to the anode. It means from the negative to the positive. Okay? The flow of current through the gap between electrode and workpiece needs column of charged particles. So we need here electrons more to flow. So that we have to see in the upcoming classes. Summary in welding. We have seen about the various positions of welding. In this we have seen about 1G, 2G, 3G positions, 4G overhead positions, 5G pipe positions, and 6G inclined positions such as 45-degree inclined positions. These things we have seen, and also we have seen about the weld zones. So remaining part we have to see them. The remaining part of the subjects we'll see you in the next session. Thank you.